So very generally speaking, a 3D printer is anything that creates 3D objects via the sequential layering of material that is usually adhered to a substrate, or it should say, is suspended in a vat or a workspace of a similar material. And we'll see what that means. And say, no, additive manufacturing can include etching and deposition. And I say, I've never heard a chemical deposition system referred to as a 3D printer, but you're going to hear it used interchangeably. A wide range of industrial applications, way too many to include on one slide. We'll get into them, but suffice it to say that it is useful from prototyping all the way through production. So there are three major branches of 3D printing: the arterial, labels, if you will. Fused deposition modeling, or FDM, is when a solid material, either a filament or pellets, in very rare instances pellets, is fed through a heated extrusion nozzle. You can see here, the nozzle is depositing Yoda's material as he's being printed. Powder bed fusion. Powder, usually a polymer or a metal alloy, is selectively fused via laser. So you can see there it's being rastered back and forth. It's actually fusing the powder together. That's a metal powder. In that case, it's metal powder. It doesn't have to be metal. And then UV polymerization. So SLA, DLP, again, we'll get into those initializations. A liquid precursor is cured or hardened by an ultraviolet light source. In this case, there's an ultraviolet light below here, and it is hardening kind of as it moves up. Just this here. Okay, so I think it's really important to give a context of 3D printing, the history of 3D printing, just to impress upon all of you how rapidly the last 5 or 6 years, 10 years, have seen the proliferation of desktop 3D printers, hobby level 3D printers, and then on the industrial side, the reduction in cost. Most of the time, some of the systems they have now are like way more expensive, but in general, the reduction in cost of these industrial scale machines that perform additive manufacturing. So in 1981, the first rapid photopolymer prototyping system was conceived of, the patent was filed, but it wasn't until 1988 that the first one was actually built. So it took almost 10 years just to even build the thing. And here you can see that tiny little bit right there is the workspace. So how little volume they had to actually print. In 91, Stratasys, which is still around today, we'll see their name, or you'll hear their name quite a bit. They patented the first fused deposition modeling system. So to remember the one that was building Yoda. And that, again, it's like that tiny little volume in there to print, and that massive refrigerator or washing machine. And then in 1997, Aeromat patented and sold the first selective laser sintering machine to fuse only one metal, which was titanium alloys. That's it, no other metals. So up until that point, the average cost per unit, industrial, or I guess at that point, there were only industrial, there were no hobby units yet, was about 40 grand, and that's not adjusted for inflation. In 2005, the RepRap project launched. The way that they got around the Stratasys patent on FDM was they actually just said, here's some instructions on how theoretically one could build a printer. Have fun. And then most of the parts were off the shelf. Some of the parts were printed by other printers that your friend might have. And then the control boards, which were not patented necessarily, were sold by RepRap or by authorized distributors. However, in 2009, that patent did expire, and a couple of different things happened all at once. Thingiverse debuted. MakerBot released the first, like, this is a 3D printer that we are selling kits. And in 2014, similarly, the SLA and the SLS patents expired. So since 2014, I guess that is 8 years ago now, the explosion in consumer level 3D printers of all flavors and the industrial explosion of 3D printers of all flavors have been due to these patents expiring. And now the average cost of printers, granted taking into account kind of a wide variety of consumer level printers anyway, is only about $350, with bigger build volumes and better quality than any of these industrial machines in the 80s and 90s ever had, give or take. What I'm not going to mention is all of this that has happened in the history of 3D printing. Scan this, Google something if you want. It's insane what has happened. A couple of highlights: the 3D printed gun controversy that is still ongoing. Who owns files, right? If I put a file on Thingiverse and then you print it and then you sell that print, do I own it? The answer is no, but similar IP issues. And then all sorts of fun advances in the space of 3D printing.